You've probably heard the term machine learning thrown around everywhere, right? And honestly, it can sound like some kind of high-tech magic. But what if I told you it's not magic at all? It actually boils down to just three core ideas, and we're going to break them all down right now. So it all comes down to this one big question. How does a machine actually learn anything? I mean, how does it go from being just a blank slate to making these incredibly smart predictions? Well, it's not a mystery. It's a process. And it turns out there are really only three main ways that this happens. All right, first up, we've got something called supervised learning. Now, the absolute best way to get this is to picture yourself studying for a test with a big stack of flashcards. You've got the question on one side, and crucially, you've got the correct answer on the back. You're learning from examples where the right answer is already provided. The secret ingredient here is that all the data is labeled. We don't just give the machine a bunch of problems. We hand over the solutions too. It's kind of like an open book test that it takes over and over and over, thousands of times, until it finally starts to see the pattern that connects the questions to the answers. Take this for example. We can show a machine thousands of house listings, and for every single one, it sees the features, the size, number of bedrooms, but it also sees the correct final price. By looking at all these examples, it starts to learn the relationship, like, okay, bigger houses with more bedrooms, they tend to cost more. And here's where it gets cool. After being trained on all those examples, the whole goal is for the machine to look at a brand new house, one it's never seen before, and make a really, really accurate guess about its price, all based on what it learned. Pretty straightforward, right? Okay, so that all makes perfect sense when you have this nice, clean, labeled data. But what happens when you just have a giant mess of information? No labels, no right answers. What if someone just handed you a box of puzzle pieces with no picture on the lid to guide you? And that brings us to our second type, unsupervised learning. Now, this is where the machine stops acting like a student and starts acting more like a detective. It's got all the clues, all the raw data, and its job is to find the hidden structures and connections all by itself. With this one, there is no answer key. We just hand the machine a mountain of raw data and pretty much just say, go find something interesting. The machine has to sift through all that noise and spot the hidden patterns or natural groupings that a human might have totally missed. Just imagine a coffee shop. It has tons of random bits of info about its customers, when they buy stuff, where they live, what they order, but there are no labels here. Nothing says loyal customer or weekend visitor. It's just data, a big pile of it. So what does the machine do? It dives into all that data and starts to discover patterns on its own. It might find that one group or cluster of people are weekday morning commuters, and a totally separate cluster are weekend pastry lovers. That process is called clustering, and it's an incredibly powerful way to find order in chaos. So, we've had the student and the detective. But what if the machine is more like an explorer, learning as it goes? Well, that brings us to our third and final type, reinforcement learning. The easiest way to think about this one is like teaching a dog a new trick. It's all about trial, error, and treats. I know, that definition sounds a little bit technical, but the idea behind it is actually super simple. You have an agent, think of it as a robot or a character in a video game, and it exists in some kind of environment. It learns by trying things out and getting feedback, either a reward or a penalty. The goal? Simple. Get the highest score you possibly can. The whole thing works in this really simple but powerful loop. The agent tries something. It gets feedback, a reward for a good move, a penalty for a bad one. It updates its strategy based on what happened, and then it tries again and again and again, getting just a tiny bit smarter with every single attempt. Think of a video game character. Over thousands and thousands of tries, it starts to learn that, hey, grabbing treasure gets me points, that's good. But hitting a wall, that loses points, that's bad. Eventually, just through pure trial and error, it figures out the perfect path to master the game and get the most points. It literally learned through experience. So there you have it, the three fundamental ways a machine learns. You've got the student with the answer key, the detective finding hidden clues, and the explorer learning from trial and error. Let's put them all side by side and see how they stack up. When you look at it like this, the biggest difference between them really just comes down to the kind of data they use. Supervised learning has to have that labeled answer key. Unsupervised learning, on the other hand, thrives in the chaos of raw, unlabeled data. And reinforcement learning? It actually creates its own data as it goes, guided only by that goal of getting a reward. And that's really the bottom line here. From the system that recommends your next movie, to algorithms that spot market trends, to an AI that can master the most complex games in the world. Pretty much every application of machine learning you see today falls into one of these three buckets. So now you know the three basic recipes for machine intelligence: the student, the detective, and the explorer. These are the building blocks behind so much of the technology that's shaping our world. And it really just leaves you with one question to think about. What problem would you teach a machine to solve?